In the journey of analyzing networks and social networks in this module, we're going to use a Python package named networkx to run some basic network analysis. The hope is using this package, you can get a better understanding of the general workflow of moving from a specific data set to creating a network and then conducting some network analysis and creating network visualizations for your own purposes. NetworkX is just one of the many options out there for network analysis. There are a lot of options both in Python and in R. For example, iGraph is a package that can be supported in both Python and R, and it's very similar to NetworkX. In the same time, there are some differences in terms of how they design their algorithms or which kind of layout they use when they generate visualizations. But in this module, we're going to use NetworkX just because it's pretty intuitive to work with, and it's very well documented. One important resource for you to be aware of is there's a NetworkX website that I suggest you can refer to when you run into any questions about NetworkX functions. So that's enough for us to get started. The first thing, if you're familiar with Python, or if you're new to Python, I'm going to walk you through some basic process of getting networks launched and set up in your environment. The first thing as you work with NetworkX is just to import NetworkX into your Python environment. You can be using your own Python setup on your laptop, or it's also very, for some of my students, especially if they don't want to set up their Python local environment, use Google Colab. For both cases, you can import or install. Of course, you install NetworkX first before you can import them. You can import NetworkX, in this case, as NX, which is a nickname for this package. And after that's done, you're ready to go, right? So, I just want to make a quick note that in this module and also in this unit, I use tools network and graph interchangeably. But they might mean different things in some other settings. But in this module, I can sometimes mention as network, sometimes I call them graph. And that's also the nature of these packages as well. Sometimes they use graph, sometimes they use network. There's no distinction between those two in this module. So with the package already loaded, now you can start to create networks. And the process is very straightforward. Here, the function to create an empty graph is to call this graph function, and NX stands for the package. So nx.graph creates an empty graph. And then from there, you can start to add nodes. You can add a node. In this case, the node is has a number or has a name as 1. And you can add 2 nodes at a time by using the brackets. And then you can add edges. You can add an edge between 1 and 2, and an edge between 3 and 1. You have 2 edges and 3 nodes in this graph. It's a very simple toy graph. So let's just you can quickly call the function draw to draw the graph. And here's what you get from that function, which shows there are 3 different nodes and 2 edges among those nodes. And of course, there are many other different options in terms of graph visualizations. Again, if you're interested in that, the best place to look into is the NetworkX reference website or reference page that I will share the link later in this video. And for example, you can call another function called draw NetworkX. This is again a generic function that's used for network visualization. You can hear by default, you see the labels are also printed. Versus the earlier case, which is just simply draw, by default, it doesn't show the label of those nodes. And you might have noticed in this network, there's for the edges, there's no direction. And that's because we created a not undirected network using the function graph. And what if you want to create a directed network or directed graph? And there's another function that is called die or D graph, which means the graph you're creating is a directed graph. And from there, we can add edges. We can add one edge from A to B with a weight of 2. And we also here, this is getting a bit more complicated, but just to demonstrate what you can do as you're adding edges. As we're adding the edge, we're adding edge attributes here. There's one attribute, weight, and there's another attribute that is about relationship. And here the relationship from A to B is family. And there you can also add another edge, C to B, and then the weight is 5 and relationship is friend. And sometimes you want to check whether a graph or a network is directed or not. So there's a function called isDirect or isDirected. You can call, and in our case, the graph we created is a directed graph. So the outcome is true. And from here, you can draw the network. And again, here's very similar. There are 3 different nodes, A, B, C, and there are 2 different edges here. And here you see the edges have arrows or directions, and the edges we created are from A to B, so A to B, and C to B. So those are 2 different edges. So this confirms our initial intention of creating this direct networks in terms of we wanted the edges or the links to be directed. And there are many other things provided by networkx, but so far in this video, you just demonstrate you can create a very simple network, and you can add edges, nodes gradually, one by one, into the network. You can add attributes in the process of adding edges or in the process of adding nodes. In the same time, networkx provides a range of data sets already baked in the library, so that it makes it easy for you to just load a classical data set from the library. One of the classical network that people talk a lot about, you can use them to use such a network to just play with, to practice different analysis. One of them is called the Karate Club graph. Was produced by Zachary in a paper that was published in 1977. So using networkx, you can call this function Karate Club graph, and this function will return a graph object already, directly for you to work with. And from there, you can run the same thing. You can draw the network using the default visualization function, and you see this is a graph of 34 different members of a karate club, because the largest number is 33, and it starts from 0, I believe. Yeah, exactly. So this is one of the classical graphs you can use to practice. And again, there are many other options provided in networkx as well, in terms of for you to just quickly launch a graph and then start to analyze the graph without going through a lot of process in terms of importing the data. And then, hope this is just the beginning, right? The video, the purpose, again, is to help us understand how to work with networkx, the Python package that is very powerful, well documented, and hopefully easy for you to get started in terms of conducting network analysis. In this course, we'll work with many other areas of network analysis. As I mentioned earlier, if you're newer to Python, it's okay. There will be some support, such as I'll provide example code for you to work with in the process of doing network analysis. And as I mentioned earlier, this is the website of networkx reference manual, which you can look into if you have questions about particular functions or particular processes of using networkx. And also, I want to mention that you are encouraged to leverage ChatGPT in the process of learning social network analysis. sometimes it's fairly straightforward, right? Without consulting the reference page, because it's sometimes hard to navigate. You don't know where to look, but you can start by asking ChatGPT for support as you're trying to complete a particular analysis. But it's important, I want to highlight that it's important to spend time to make sense of the outputs, and so that you understand what the code provided by ChatGPT is doing. And also, it's important to be transparent and responsible as you're leveraging this new tool for learning and for analysis. That's all for this video. I'll see you in the next one.